Welcome to the Daily AI Brief, your source for the latest developments in artificial intelligence. Today, we're diving into innovative releases, groundbreaking research, and dynamic technologies that are shaping the AI landscape. Whether you're spearheading AI projects or exploring the sector, we have insights tailored for you. Stay tuned as we unpack these fascinating stories and their implications. OpenAI is making headlines this week with the much anticipated launch of its latest language models, GPT 5.6 Sol, Terra, and Luna. These models are not just about advancements in AI capabilities, but are also a testament to navigating a complex regulatory landscape. What happened is OpenAI has decided to release these models on Thursday after a temporarily delayed launch due to regulatory scrutiny. Initially, these models were only accessible to a limited group of trusted partners, adhering to U.S. government concerns about AI oversight. Now, the restrictions are lifted, opening the gates for broader usage. Technically speaking, the new models have been built on the architecture of their predecessor, GPT 5.5. Consider the following enhancements. Sol is the flagship model, equipped with a robust safety stack designed to enhance cybersecurity capabilities significantly, promising 30% greater efficiency compared to GPT 5.5. By integrating advanced cyber defense mechanisms, Sol aims to be a frontrunner in AI safety. Terra offers a balanced act between performance and cost efficiency, maintaining performance while operating at half the cost of previous models. This presents a significant draw for businesses demanding robust AI solutions without the premium price tag. Luna is tailored for speed and affordability, boasting a 25% reduction in response time latency. This makes it an ideal choice for real-time applications where responsiveness is key. Integration with these models is facilitated through OpenAI's API and Codex, which provide comprehensive tools for developers to incorporate advanced AI functionalities into their applications. This approach ensures that even complex tasks can be handled by utilizing sub-agents in max reasoning or ultra mode. However, these advancements come with potential drawbacks. There's a concern about the model's adoption amidst stringent regulatory scrutiny and how it might affect long-term availability. Questions about the safety feature's effectiveness during real-world application remain, and their reliability is still under independent review. Practically, developers keen to explore these models can start by accessing them through OpenAI's API with simple commands like curl_x post request.json 8squal/api.open.com/v1/models. Comprehensive documentation available on OpenAI's site will assist in seamless integration, and engaging with developer forums can provide valuable feedback and support. In summary, while navigating a potentially turbulent regulatory environment, OpenAI's release of these models underscores the essential balance between innovation and compliance, a tightrope AI developers must walk today. This release signifies a broader trend of AI innovation amidst stricter reevaluation from government entities and may set a precedent for future developments contingent on governmental guidelines. NVIDIA is pushing the boundaries of AI efficiency with the launch of Nemotron Labs 3 Puzzle 75B A9B, a compressed version of their popular large language model series. This new model promises to enhance server throughput significantly, catering to environments that demand not only high performance, but also scalability and cost-effectiveness. The Nemotron Labs 3 Puzzle 75B A9B achieves approximately twice the server throughput of its predecessor, Nemotron 3 Super. This significant enhancement does not compromise user throughput constraints and is facilitated by techniques such as iterative puzzle compression, knowledge distillation, and reinforcement learning, all working in tandem to achieve such performance metrics. Delving into the technical aspects, the model architecture combines heterogeneous mixture of experts, MOE, with advanced Mamba transformer configurations. These enhancements are critical as they enable multi-token prediction, MT layers. These layers significantly enhance text generation speed, allowing the model to process multiple tokens simultaneously. Compression techniques. The implementation of quantization and pruning methodologies ensures streamlined inference processes, reducing redundancy without losing significant performance accuracy. Mamba pruning mechanisms. These are employed within the heterogeneous MOE architecture to optimize the allocation and utilization of parameters more effectively across various segments of the model. When it comes to performance numbers, the model demonstrates its prowess by handling up to 8 concurrent requests on a single H100 GPU. It reduces active parameters from 12.8 billion to 9.3 billion, and total parameters from 120.7 billion to 75.3 billion. This reduction is not just about smaller size, but translates directly into handling a million token context with remarkable efficiency, a necessary capability for applications requiring extensive contextual understanding. Despite these advancements, compressing a language model isn't without its trade-offs. While efficiency increases, potential performance compromises warrant thorough investigation, particularly concerning real-world applicability. Moreover, integration challenges with current hardware ecosystems require meticulous assessment to ensure seamless operation across various infrastructures. For practitioners interested in leveraging this technology, NVIDIA has made the model accessible via a Hugging Face repository. This enables developers to test its capabilities in real-time data processing and interactive AI services. Running benchmark tests and comparing throughput and accuracy against legacy models can provide insights into the model's efficacy and adaptability in diverse scenarios. In summary, NVIDIA's release of the Nimotron Labs 3-Puzzle 75B A9B signifies a substantial leap forward in developing efficient, resource-light AI solutions. This model sets the stage for innovative LLM designs that could redefine industry standards, supporting enterprise requirements for scalability and throughput while minimizing operational costs. Google AI Studio is stepping up its game with the planned integration of a new feature that allows developers to import code directly from GitHub, optimizing development workflows considerably. This marks a significant innovation in the field of full-stack application development. Currently, this feature is in internal testing and aims to deliver seamless imports of entire repositories into Google AI Studio without a confirmed public release date. Historically, the platform allowed project exports to GitHub, but this new capability will let developers bring existing codebases into the AI Studio environment, marking a complete shift in development paradigms. Technically, the integration involves several key components. Seamless synchronization. This capability revolves around establishing a direct sync with GitHub, allowing for the continuous integration and import of new commits from remote repositories into AI Studio. Developers can ensure that the codebase remains current without redundant manual updates. Enhanced build mode. Once inside AI Studio, users can leverage its build mode for executing full-stack applications. This mode is geared towards enabling developers to not only build, but also test, deploy, and iterate on their applications using advanced generative AI models, enhancing the speed and efficiency of application development. Framework support and flexibility. While specific frameworks supported through this integration have yet to be confirmed, the aim is to accommodate an array of programming environments. This will likely affect the utility for developers who rely on diverse coding languages and environments. Efficiency in prompt testing and code generation. AI Studio's tools will facilitate rapid prototyping via automated code generation and prompt testing, drastically reducing the development cycle and allowing for faster innovation. However, the introduction of this feature is not without its limitations and considerations. Latency and performance metrics. Detailed metrics for latency and system performance remain undisclosed, presenting an uncertainty for developers who require high-speed, reliable integration tools. Cost implications. Without concrete cost estimates, fiscal budgeting and planning for using this new feature could be complex, particularly for startups or independent developers. Complexity handling. Integrating large-scale projects might pose challenges, especially if the repositories contain intricate dependencies or unsupported code frameworks. Developers may need to preemptively strategize how to break down or modularize their codebases for a smoother transition. For developers eager to leverage this upcoming feature, there are several proactive steps to take. Stay informed via official channels. Regularly monitoring Google AI Studio's official documentation will provide the latest implementation updates and usage guidelines. Engage with the community. Participate in developer forums and Google AI Studio discussions to gain insights and early feedback from fellow developers, allowing for knowledge exchange and anticipation of practical workarounds. In conclusion, Google AI Studio's planned GitHub import feature is an exciting development with the potential to significantly streamline AI-driven application development, pending final launch and broader availability. SpaceXAI has officially released Grok 4.5, an advanced AI model meticulously designed to excel in coding, finance, and strategic knowledge work. This state-of-the-art release brings significant advancements to the table, positioning it as a formidable player in the AI market. Grok 4.5 has distinguished itself by topping Harvey's legal agent benchmark, underscoring its potential in highly specialized domains. This model offers a compelling price point at $2 per million input tokens and $6 per million output tokens, strategically placed to compete with established models like OpenAI's GPT series and Anthropic's Opus. The technical foundation of Grok 4.5 is significantly bolstered by SpaceXAI's recent acquisition of Cursor, a startup focused on agentic applications. Key technical features of Grok 4.5 include extensive data training. The model is trained on expansive data sets that span disciplines such as coding, engineering, and the sciences, preparing it for diverse applications. Cursor infrastructure. Enhanced coding applications are supported by the robust infrastructure from Cursor, allowing for real-world task engagement. Adaptive API design. Its APIs are crafted for seamless integration with existing enterprise tools and developer platforms, enabling ease of use for businesses. GPU optimization. Grok 4.5 is fine-tuned for performance on the NVIDIA GB300 GPU architecture, ensuring efficiency in token processing and optimized computational workloads. In terms of benchmarks, Grok 4.5 showcases impressive metrics, including enhanced efficiency in token utilization and reduced processing times compared to its predecessor, Grok 4.1. This efficiency is backed by the use of tens of thousands of NVIDIA GPUs, underscoring the model's robustness and capability to handle extensive computational demands. Despite these advancements, some aspects remain unverified, particularly its direct performance comparisons with leading models such as GPT 5.5 or Opus 4.7. This leaves room for speculation within the AI model hierarchy. Moreover, the long-term sustainability of its aggressive pricing strategy is an area for observation, especially in the face of rising development costs. To explore Grok 4.5 further, developers and businesses are encouraged to visit SpaceXAI's official documentation, experiment with its sector-specific applications on integrated platforms like Cursor, and run benchmarks to evaluate its real-world performance against other prominent models. In conclusion, Grok 4.5 exemplifies a significant leap forward for SpaceXAI, poised to reshape the landscape of AI-driven coding and knowledge work. Its potential to alter competitive dynamics could prompt a reevaluation of cost structures and performance standards across the industry. Robbyant has taken a groundbreaking step in advancing robotic manipulation with the introduction of LingBot-VLA 2.0, an open-source vision language action (VLA) model unveiled in July 2026. This state-of-the-art model is meticulously designed to enhance the manipulation capabilities of a wide range of robotic configurations. By leveraging an extensive pre-training dataset comprising 60,000 hours, 50,000 hours dedicated to robot interactions, and 10,000 hours to human manipulation, LingBot-VLA 2.0 has significantly broadened its application scope. The technical sophistication of LingBot-VLA 2.0 is evident in its architecture, which accommodates a variety of robotic morphologies, including single-arm, dual-arm, bipedal, and wheeled designs. The model integrates advanced coordinated control features that manage multiple robot components such as heads, waists, end effectors, and chassis, thereby maximizing manipulation proficiency. Its optimized architecture ensures latency remains impressively low, consistently maintaining levels under 130 milliseconds when operated on an NVIDIA RTX 4090 GPU. Performance-wise, LingBot-VLA 2.0 excels on the GM100 benchmark, surpassing previous leading models like Pi.5 and GR0T N1.7 in dual-arm tasks. Despite this achievement, it's important to note that some performance metrics still await independent verification, raising questions about the model's effectiveness in diverse and uncontrolled real-world scenarios. For developers and researchers, the open-source nature of LingBot-VLA 2.0 offers a robust platform to experiment with various robotic applications. By trying the available codebase on GitHub, teams can explore integration possibilities across different platforms, potentially unlocking new robotic capabilities. From a commercial perspective, the implications of deploying LingBot-VLA 2.0 are vast. Its ability to enhance manipulation tasks could transform industries like retail, logistics, and automation by reducing costs and speeding up deployment times. Additionally, its customization potential means it can be tailored to specific industry requirements, thereby setting new standards in robotic intelligence and efficiency. Yet, despite these promising capabilities, LingBot-VLA 2.0 faces challenges. The scalability of the model over extended periods and its performance across broader robot platforms remain subjects for further research. Moreover, its efficiency in unstructured environments compared to controlled settings demands more exploration. In essence, Robbyant's latest model presents an exciting opportunity for significant advancements in robotic manipulation, poised to influence future developments and spur further research in the field of embodied AI. Netflix's AI team has introduced a dynamic partition splitting mechanism to enhance read latency in Apache Cassandra, a crucial advancement that optimizes database performance significantly. Implemented in June 2026, this strategy tackles the pervasive challenge of oversized time series partitions that often result in increased read timeouts and high CPU usage, reducing latency from seconds to low double-digit milliseconds. Technical breakdown. Netflix's approach employs a sophisticated asynchronous pipeline specifically designed to detect and manage partition splits for those exceeding 500 megabytes. Key elements include dynamic partition splitting. This mechanism operates on an individual ID level, ensuring that each partition is evaluated and split as necessary. By dynamically adjusting partitions, the system prevents them from growing to sizes that could degrade performance. Automated partition evolution framework. At the core of this strategy is an automated framework that meticulously maintains metadata related to partition boundaries. This framework ensures that each adjustment is logged and can be reversed or modified without causing downtime. Time bucket interval adjustments. The system intelligently adjusts time bucket intervals based on the observed size of partitions. This optimization further aids in managing and distributing data efficiently, contributing to latency improvements. Achievements and metrics. The implementation of these techniques has markedly decreased system latency. For wide partitions, latency metrics have dropped to approximately 200 milliseconds. Moreover, there is a noted reduction in CPU utilization and read timeouts, enhancing system stability. Operational considerations. The rollout of this mechanism was strategically planned to cause no application disruptions. During the transition, original partitions are retained, ensuring operational safety and continuity. This non-disruptive approach allows ongoing processes to remain uninterrupted, maintaining consistent system availability. Trade-offs and challenges. While this solution primarily addresses immutable partitions, its application scope is somewhat restricted. Future enhancements may confront difficulties in adapting to mutable partitions, where data can be updated frequently. Additionally, the long-term impact across various workloads remains to be validated thoroughly. Steps for implementation. To explore this innovative approach, developers are advised to consult Netflix's comprehensive tech blogs, which offer in-depth insights into the dynamic repartitioning measures. Experimentation with the automated evolution framework in controlled environments can provide practical exposure to its capabilities. Broader implications. Netflix's initiative is not just a triumph in optimizing Cassandra for their use case, but sets a precedent for how dynamic partition management can be applied across other distributed database systems. It opens opportunities for significant operational savings and inspires further innovation in automated data management tools. In conclusion, Through methodical and innovative engineering efforts, Netflix has delivered a compelling resolution to the challenges posed by wide partitions in time series data management. This solution underscores the potential shifts in data handling ideologies and highlights areas ripe for future exploration and development in database system management. Datalab has introduced Lift, a groundbreaking tool for document extraction using a schema-first approach, poised to redefine data handling in various industries. Released in June 2026, Lift is built on a formidable 9 billion parameter model, achieving a notable field accuracy of 90.2% on a stringent benchmark of 225 documents. This positions it as one of the most precise models available today for small, self-hosted environments. Its main functionality is transforming structured data from PDFs and images into a JSON format, processing each document in a median time of approximately 95 seconds, enabling a more streamlined approach to handling large volumes of information. Technical insights. The architecture of Lift allows a deep dive into its schema-first methodology, which is its hallmark. This involves schema-driven extraction. Users input a JSON schema that dictates the extraction process. This focus on schema first allows for remarkable flexibility, enabling users to adapt the model's operations to meet specific document formatting needs. OCR integration. Lift leverages existing Datalab OCR technologies like Chandra, Marker, and Surya to enhance performance further, ensuring accuracy and efficiency are maintained across diverse document types. Open weights architecture. This feature enables more accessible customization and fine-tuning, allowing businesses to mold Lift to suit their specific requirements, whether it's handling contract details, invoices, or intricate report structures. #Azure performance metrics and comparison. Lift operates with a median processing time per document, significantly optimizing workflows. When compared to competitors, it presents a slight disadvantage in accuracy relative to models such as Gemini Flash 3.5, which achieved a 91.3% accuracy rate. However, the ease of integration and customization with Lift offers substantial counterpoints. Applications and considerations. Potential applications for Lift are broad, spanning industries like finance, healthcare, and legal, where accurate data extraction is crucial. However, it's important to note that its effectiveness on unconventional document layouts is yet to be fully validated. Additionally, the schema-driven design necessitates certain technical expertise, potentially limiting accessibility for enterprises lacking such resources. For practical engagement, Datalab provides extensive API documentation to facilitate integration into existing systems. Curious developers and businesses can experiment with Lift via demos available on platforms such as Face Model Hub, ace.co/datalab2's Lift UTIM source OpenAI, exploring potential use cases firsthand. Future implications. The broad adoption of Lift could transform document processing, leading to cost reductions in data handling tasks. Moreover, its open weights nature fosters personalization, promoting broader research and development in schema-driven methodologies. If these practices gain traction industry-wide, they might stimulate competitors to innovate further, enhancing the data extraction landscape as a whole. In summary, Datalab's Lift marks a significant step forward in document processing technology. By marrying a robust model with a flexible, user-driven approach, it promises to elevate the efficiency and accuracy of data management systems across industries. Evaluating AI performance within continuous integration (CI) environments has become an essential part of modern AI workflows, driven by innovations like Arize Phoenix. As AI systems become more complex and integral to operational processes, the challenge lies in assessing their performance efficiently and effectively. Arize Phoenix steps into this niche with its open-source capabilities, offering detailed tracing and evaluation tools. A critical feature of Phoenix is its ability to support both deterministic evaluations and LLM as a judge approaches. This flexibility allows it to seamlessly integrate with existing CI pipelines, ensuring robust and reliable assessments of AI models. Phoenix's methodological prowess is underscored by its integration mechanisms. It works hand in hand with OpenTelemetry, a leading open-source platform for monitoring software, which enhances Phoenix's observability capabilities. By embedding itself within CI workflows, Phoenix allows real-time evaluations, making it easier to catch and rectify performance regressions swiftly. The tool incorporates advanced features such as prompt engineering and scenario-weighted readiness scores. These scores provide AI engineers with a nuanced understanding of model performance, going beyond simple metrics to offer a comprehensive view that can guide improvements and optimizations. Additionally, Phoenix supports data exporting functionalities, enabling further analysis and refinement outside the immediate CI environment. Numbers and limits. One notable benchmark is Phoenix Bench, which evaluates 511 Verilator instances sourced from 114 GitHub repositories. However, while these figures showcase Phoenix's potential in scenario testing, its scalability in real-world large-scale applications still necessitates further practical validation. Practical steps. For AI engineers looking to leverage Arize Phoenix, several resources can facilitate the initial setup. Detailed documentation is available, guiding users through the functionalities and potential integrations of Phoenix. Newcomers can explore setups via the GitHub repository and related resources, ensuring a smooth integration into existing CI frameworks. Trade-offs and potential. Despite its advantages, potential trade-offs include the initial integration challenges into existing pipelines and possible limitations in evaluating hardware engineering tasks. Moreover, reliance on OpenTelemetry might be a barrier for organizations using different observability tools. Conclusion. Arize Phoenix signifies a transformative approach to AI evaluation methodologies. By shifting towards a more systematic and automated framework, it enhances the confidence of AI deployments and could set new industry standards. While the full validation of its effectiveness at scale remains to be seen, its current capabilities promise a significant improvement over traditional methods, laying a foundation for more scalable, robust AI performance assessments in CI environments. That's it for today's episode of the Daily AI Brief. We've covered significant innovations and technical improvements driving the AI landscape forward. Stay informed by following our podcast for more updates. We'll see you tomorrow with more exciting developments in the world of AI. Thank you for tuning in.